Good morning, students. This is your third class from the chapter 1, Electric Charges and Field. The topic which we are going to discuss today is your Coulomb's law. Now, I think most of you know what is Coulomb's law. Here we are trying to explain elaborately. Now, in the figure you see, we have considered 2 point charges Q1 and Q2 separated by distance r. Now, as per the Coulomb's law, it says that if you place 2 point charges near to each other, what happened basically, there is an influence, or you can say there is a force between the 2 point charges, and the force may be attractive or repulsive depending on the nature of the charge. Now, the factor on which this force depends can be explained using Coulomb's law. Now, as per the Coulomb's law, it says that the magnitude of force of attraction or repulsion between any 2 point charges at rest is directly proportional to the product of the magnitude of charges and inversely proportional to the square of the distance between them. It means if the product is high, the force is high. If the product is less, the force is less. Product between two charges Q1 and Q2. And if the separation is high, the force is less, and if the separation is less, force is high. That's inversely proportional. Now, the mathematics part, here we have stated if capital F be the forces between 2 point charges, then number 1, F proportional to Q1, Q2, that is the product, and F proportional to 1 by R square. Now, combining these two, you will get F proportional to Q1, Q2 by R square. So, if you want to bring one constant, then it becomes F equal to K Q1, Q2 by R square, where K is the constant of proportionality, and it depends on the number 1, the system of unit, and the nature of the medium in between the two charges. Okay. So K is constant and it depends only on the two factors. One is your system of unit, on what system you are considering the force, charges and distance, and another one, the medium between the 2 point charges. If the medium is rarer, then the force will be high. If the medium is denser, the force will be less. It means if the medium is rarer, then more influence will pass from one charge to the other, and if the medium is denser, less influence will pass. It's very simple. Now, this constant depends on two factors. One is your system of unit, and another one is your medium between 2 point charges. Now, in SI system, this K basically, which we have shown in equation 3, is K equal to 1 by 4 pi epsilon, where epsilon, this curve is your epsilon, where epsilon is the permittivity of the medium. Permittivity means what? It is some kind of allowness. Allowness of what? Allowness of influence from one charge to the other. That's why it comes from the permission, allowness. That comes from this word, and it defines permittivity of the medium. Now, you can further split epsilon as your epsilon naught, epsilon r. Epsilon naught is your absolute permittivity, and epsilon r is your relative permittivity. The subscript small r defined relative. So K equal to 1 by 4 pi epsilon naught epsilon r. Now, if you substitute K in equation 3, what you will get? This equation 4 you will get 1 by 4 pi epsilon Q1 Q2 by R square equal to 1 by 4 pi epsilon naught epsilon r Q1 Q2 by R square. In air or vacuum, epsilon r comes to be your 1. So it's your 1 by 4 pi epsilon naught Q1 Q2 by R square. So equation 5 is the master equation which you are going to use in numerical. And now you can find the value of 1 by 4 pi epsilon by substituting the value epsilon naught. Okay, so you will get the value of epsilon naught in any standard textbook or reference book. You substitute that value and try to find out 1 by 4 pi epsilon naught. Now 1 by 4 pi epsilon naught comes out to be your 9 into 10 to the power 9. So check it out whether it comes to 9 into 10 to the power 9 or not. You substitute the value of pi 3.14, substitute the value for epsilon naught, check it from your textbook or reference book. You will get the constant value epsilon naught and substitute and try to check out the value. The value 1 by 4 pi epsilon is equal to 9 into 10 to the power 9. Now you can define for air or vacuum epsilon r equal to 1. So 1 F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. For medium, it is your 1 by 4 pi epsilon. So we are trying to find the ratio F air by F medium, So 1 by 4 pi epsilon naught q1 q2 by r square, that is for air. For medium, 1 by 4 pi epsilon q1 q2 by r square. So on simplification you will get epsilon by epsilon naught. So substitute the value for epsilon, it is your epsilon naught epsilon r. So epsilon goes up, that is your epsilon r. So epsilon r is your relative permittivity. So if you check out, force for air is relative permittivity times the force in the medium. So the force is more in air rather than the force on the medium. Definitely air is lighter and medium is denser, that's why force is higher. So in rarer medium, the influence can easily pass from one point charge to the other charge. Now from this FAR by F medium, we are getting epsilon r, that is a relative permittivity, and we are trying to define the statement. So the statement is like this: the relative permittivity of a medium is defined as the ratio of the electrostatic force between 2 point charges placed in air to the force between same 2 point charges placed in medium. So this is very simple, only the statement you have to write from the expression. Now SI unit of permittivity, so we are using the equation 5. Equation 5 is your 1 by 4 pi epsilon naught q1 q2 by r square, or you can say you can use the equation 4 also. F equal to 1 by 4 pi epsilon q1 q2 by r square. Epsilon comes out to be your 1 by 4 pi f q1 q2 by r square. So unity definitely you can say Coulomb square, charge Coulomb square, per Newton per meter square. And for dimension, you have to substitute for q1 q2, that is your a2 t2, and force is your m1 l1 t minus 2, and distance is your l2. So on simplification you will get m minus 1 l minus 3 a2, and t comes out to be your 4. So m minus 1 a2 l minus 3 t4. Now regarding limitation, basically this Coulomb's law valid for the point charges at rest. It is not valid for the extended charge. So this is one limitation. So we have written it holds good for point charges at rest. And also for distances less than 10 to the minus 15 meter, it loses its validity. So if you consider the nucleus, the radius is very less than this value, 10 to the power minus 15 meter. So within that protons resides, but there is no Coulomb's force exist. Otherwise, if Coulomb force exists, then definitely inside the nucleus protons can't reside. So inside that smaller region or inside the nucleus, there is one kind of force, that is your nuclear force, and it is charge independent. Now this force basically depends on the medium. We have just now shown that if it is air, then the force is high compared to the medium. So it is a medium dependent law. So these are the limitation of Coulomb's law. So please go through this part, and in next class we are going to define a vector form of Coulomb's law. So this is all about, it's a very simple, and here what you will do, you will try to find the value of 1 by 4 pi epsilon naught by substituting the value for epsilon naught. Check out any reference book or textbook, you will get the value for epsilon naught. Substitute that value and try to find out 1 by 4 pi epsilon naught. You will get 9 into 10 to the power 9. So check it out. So this is all about, this is the third number of class from the chapter 1, electric charges and field. So do study and find out your doubts and clear your doubts. Thank you.